So let's start with a new topic. How do we create our own large language models? So now we know that we have Hugging Face open source framework for all the available large language models, where we can build our own large language models where we can build our own large language model for a specific use case. We want it for product, we want it for finance, depending on our use case. How can we build a large language model using code? So when we say code, so code is going to be Python code, because Python is the language for data science, artificial intelligence. It is easy to use. It can be used by anyone. And the platform that we are going to use is Google Collab. So when we say platform, so when we discuss about large language models, these models are trained on huge corpus of text, and they are really heavy. That means they need good hardware. They have a very huge hardware requirement. So to get that hardware requirement easily, we have this platform. We always have an online platform available. So one such platform is Google Collab that we are going to make use here. So we have created this. So first, let's create a summarization model using Facebook's BART. So from transformers. So when we say Hugging Face, the library or the extension that we are going to use in Python to create a large language model is transformer. Inside transformer, we have a specific function, pipeline function. So this pipeline function is created to perform specific tasks tailored to our needs. So we have got this transformer from pipeline, we have got pipeline from transformer, and we have created a summarizer. So inside pipeline, we have informed what kind of task we want to perform today. So that task is going to be summarization. The model that we are going to use today. So the model is Facebook's BART large language CNN. And we have given a corpus. Let's run this corpus now. And it is going to generate the text for us. So we have discussed so far, okay, we are in the era of Gen AI. That means artificial intelligence systems generating audio, text, videos for us creatively for any domain, and it is able to understand us and generate relevant topic as well. When we use these Gen AI models, the trick behind them is the recently created architecture, that is transformer architecture. When we use these transformer architecture on large amount of data, we get an outcome of large language models. So to get hands-on on all the available large language models, we discussed we have Hugging Face library available. That is free of cost. We can make use of any large language model available. But to use these large language models, we require good computation, that is good hardware. So to get easily available hardware, we have companies like Google, Facebook, they have their own online interpreter. So today we are using Google Collab. That is one of the online interpreter where we are going to get the required hardware for the large language models and create our own large language models here. So first, to use large language models, the Hugging Face library goes by the name of transformers. That is, to make Python adaptable for these large language models, we are adding a new extension called as transformers. That is the Hugging Face library. So from transformer, we are importing this pipeline command here. This pipeline command is created in such a way that it is going to handle many different use cases for us. That is speech recognition, question answering for us, document summarization for us, image classification. Depend on the task required, we can configure this pipeline. So first, we are going to use it for summarization. So pipeline function, we are making use of summarization. Task and model, we are making use of Facebook's BART large language model. So we have given a huge corpus of text to this large language model. This is a story that needs to be summarized for it. We have passed it to the large language model and it has generated a summary for us. 3 brothers and 7 camels left by their father. It continues and finally it gives us a small summary and tells us more to find out more by reading this story. So to create this, we made use of transformers library and we have made use of pipeline function. Inside pipeline function, we made use of summarization task. Let's use it for some other tasks here with another model. And again, now we have made use of pipeline function with question answering bot to create a question answering chatbot, a generative bot. Model we have used here is BART based undistilled squad. So model we have used here is distill BART based cased distilled squad. We have given a context to it. We know that these large language models are built upon general data. But when we want to build this on a context, we have given the context. The Taj Mahal was built by Shah Jahan in memory of his wife, Mumtaz Mahal. So we have given a context to it. Now the model knows about this thing. It knows how to speak with this person and it knows this context. Now we are passing a question to it. Who built the Taj Mahal? For the answer, we are giving the question and we are giving the context. Now the job of this large language model is to go inside this context and give us the relevant answer. Upon execution, it is answering Shah Jahan for us. So next use case, sentiment analysis. We use this very commonly. Let's say we are a product manager, we have millions or thousands of reviews on a product. How do we know those products are positive or negative? Yes, we have been using traditional machine learning techniques to understand a good or a bad sentence. But there is sarcasm hidden inside those sentences. There is a different meaning behind those sentences. So to get the right review about those reviews on a product, we can make use of this sentiment analysis bot here. So we have a pipeline. This time the pipeline function, we have set it up for sentiment analysis and we are passing a review. I love this product. It works like a charm. Result is equal to sentiment. And let me pass a model here. The model got this. So let's use it for the next task here. That is sentiment analysis. Model we are making the model we are using here is GPT-2 model. Review we are passing is, I love this product. It works like a charm. Result, we are passing this sentiment bot that we have created with the review that we have. And upon running, it has given us a label of 1. So 1 being positive, it is telling us that the label is 1 for us. That the review given is positive. Similarly, let's go ahead and build a text generation. So using the pipeline function from transformer, we have set up a task as text generation. Model we are making use here is GPT-2. And we are asking this thing to write a poem about data science. Let's run this thing. Informed it to generate 50 words and just repeat it once. So let's also consider the training time here. The output answer time here. Being a specialized hardware, still it is taking time. So that's the reason, at the beginning we mentioned, when we use these AI models, the Gen AI models, they are really heavy for computer hardware. That's why we make use of such online interpreters. It has generated a poem for us. Use the word data science to describe a topic and it is giving us some information. The information doesn't seem that relevant to what we have asked. No issues, we'll come to this again. So we asked this thing and it is generating a corpus for us. Similarly, name entity recognition. So for name entity recognition, we are passing a sentence. From this, it is supposed to identify humans, influential humans or name of a human, positions and companies. When we run this thing, it is telling us that entity group is person, score is this much, score is really high 0.99 and the word is Elon Musk. Similarly, it has identified an organization inside this and that is Tesla and the starting position and ending position. Same goes for the SpaceX. It has identified another organization and it starts at 34 and it ends at. So there are many use cases that we have here that we can use, but observe one thing. When we are making use of these models, these models are not giving us that clean output that we need. So how do we get that clean output using the already available ChatGPT models, DeepSeek models? We are going to discuss in the next topic. Thank you.